Children, having understood now what is equation of line and what are different ways to represent equation of line, let's move further with the next question. What is our question trying to say? Our question says point m comma 2m minus 1. So we have a particular point whose coordinates are m 2m minus 1, x coordinate being m, y coordinate being 2m minus 1, lies on a line 3x by 5 minus 2y by 3 equals to minus 1. So equation of line is given to us. Find the value of m. Find the value of m. Let's understand this particular sum in much better way by just analyzing our own diagram. Mind you, it's not necessary and compulsory to draw the diagram. It's only to make you all understand. So say for example, we have this line graph. We do have this particular line graph whose equation is given to us. The equation of this line graph is 3x by 5 minus 2y by 3 is equals to minus 1. Now children, how many points do this particular line has? Line has infinite points. This particular line graph whose equation is being stated has n number of points. What is the condition then? The condition is every point lying on this line graph, or rather let me say the coordinates of every point lying on this line graph should satisfy the equation of line. I repeat, there are infinite number of points on this particular line. The coordinates of every single point should satisfy the equation of line. Given to us one particular point, so let me say there is one point, name is not given, so even we are not naming it. Say this is particular point whose coordinate is m comma 2m minus 1. On the same lines, the coordinates of this particular point should satisfy the equation of line. Means what? We need to substitute x as m and we need to substitute y as 2m minus 1. Why? Because the coordinates should satisfy the equation of line. Why so? Because point lies on the equation of line. Right children? So we start our solution as, since point m comma 2m minus 1 lies on the line 3x by 5 minus 2y by 3 equals to minus 1. Therefore, the coordinates of point should satisfy the equation of line. Should satisfy the equation of line. So we just need to substitute. Therefore, substitute x is equals to m and y equals to 2m minus 1 in the above line graph. Instead of x, we shall substitute m. Instead of y, we shall substitute 2m minus 1 in the above line graph. So once again, let's write down the line graph. 3x by 5 minus 2y by 3 equals to minus 1. 3 into, instead of x, it's m by 5 minus 2 into 2m minus 1 by 3 equals to minus 1. What is LCM between 5 and 3? 15. So let's say multiply by 15 on both the sides. Multiply by 15 on both the sides. So when I multiply this by 15, so let me write down this as 3m by 5 minus 2 m minus 1, 2m minus 1 rather, by 3 is equals to minus 1. We are multiplying by 15 throughout. So when I multiply this by 15 into 15, every single term needs to get multiplied into 15 into 15. What now children? 1 times 3 times, 1 times 5 times. You could have gone for LCM in this way by saying cross multiplication, but that's not the right way to write down. 3 3s are 9, so it's 9m minus 5 into 2, it's 10, so it's 10 into 2m minus 1 is equals to minus 15 children. We don't have any denominator. 9m minus 20m plus 10 is equals to minus 15, children. Bring all m's on one side, constants on other side. So 9m minus 20m is minus 11m minus 15 plus 10 goes over there, becomes minus 10. So minus 11m is minus 25. Can we cancel the negative side on both the sides? Indeed we can, and we should. So cancelling this negative sign, what do we get? 11m is equals to 25. M is equals to 25 by 11. So the value of m is nothing but 25 by 11. So what we have learned in this particular sum, children, right? That if a particular point lies on the line graph, then coordinate of that particular point always satisfy the equation of line.